This question is taken from Edexcel IAL Physics, June 2020. So this is from the particle physics. Cloud chambers are used to observe the paths of particles. The photograph shows a pair of tracks made by alpha particle emitted when an atom of radon decays in a cloud chamber. So two track is given, track 1 and track 2. There is a related question, but these two question student can solve easily, but most of the time students are facing problem with the second question. Question is, radon atom was stationary before the first alpha emission. The angle between the two alpha track is 60 degree. Sketch a vector diagram to show the momentum of the two alpha particles and the lead ions. So according to question, they just told radon decays by emitting an alpha particle, producing a polonium nucleus. So initially radon is at rest and it producing alpha particles, and according to question that alpha particles moves in this direction. As we know that radon is at rest, so ultimately to equalize the momentum, the produced polonium that moves to the upward direction, because momentum before decays, that is 0, and momentum after decay, that would be 0. So if this one is for the alpha 1 and the upper one would be for polonium. In the next condition, polonium decays immediately. It also emits another alpha particle. So this is polonium. According to the question, the second alpha particle that decays like by maintaining 60 degree to the first alpha particle, so that one would be this direction. As this decay occurring from the polonium, so momentum would be conserved. That means as this one is like this direction, so to equalize this one, the vector would be like this, but I just have to draw this one in separately, like this is polonium now, and this polonium is moving in this direction. From the polonium, alpha 2 is emitted, that is in this direction. So ultimately the lead would move to this direction, because the resultant of the alpha 2 and the lead would be equal to the resultant of polonium. The momentum of polonium would be equal to the momentum of alpha 2 and lead, momentum of lead. So now alpha 1 moving in this direction, alpha 2 moving in this direction. So the resultant of these two alpha, again this is alpha 1, this is alpha 2, and resultant of the two alpha is this direction. And another concept is alpha 1 moving to the downward direction, that means polonium that is equal and opposite of the alpha 1, and polonium that is the resultant of alpha 2 and the lead, so lead would be in this direction. So combinedly all of this can drawn like this. This is alpha 1 and there is alpha 2, and this is the lead. Now the next question 17v3, determine the magnitude of the velocity of the lead ion, velocity of alpha particle that is given, velocity of alpha particle actually emitted by the radon is given, velocity by of alpha particle emitted by polonium, that is also given. Mass of lead ion is given. The mass of alpha particle, that is it's contain 2 proton and 2 neutrons. So ultimately you can easily calculate the mass of alpha particle by multiplying the mass of proton or neutron by 4. So according to our question, we just have to calculate the velocity of lead ion, that is the question. All other information are given. We can simplify this triangle, like from A to B, that information is known to us. Even from B to C, that information also known to us. So if we can determine B to D and D to C, then easily we can apply the Pythagoras theorem. That means AD square plus DC square equal to AC square. For the simplification, I just can draw another diagram, like this is alpha 2 and there are 2 components of the alpha 2, like if this is the resultant, and as the angle is 60 degree, so this component would be alpha 2 cos 60 degree, and that one would be alpha 2 sine 60 degree. Then ultimately if we compare this one with this diagram, so this one would be alpha 2 cos 60 degree, and this part would be alpha 2 sine 60 degree. Initially you just have to calculate the momentum for alpha 1, then we have to calculate the momentum for alpha 2. According to this diagram, we have to calculate the vertical component of alpha 2 and horizontal component of alpha 2. Vertical component for alpha 2 would be alpha 2 cos 60 degree. The horizontal component for alpha 2, that one would be alpha 2 sine 60 degree. Here this is the right angle triangle. We have now all of the information, momentum of alpha 1, even the vertical components of alpha 2, horizontal components of alpha 2. So easily we just can, ultimately we can write this AC square equal to AD square plus DC square, or AC square equal to AB plus BD whole square plus DC square. Then by solving this, easily we can calculate the momentum of lead. As we know that momentum equal to mass into velocity, then from the momentum easily we can calculate the velocity of lead.